Hello, and welcome to section 3.5, which deals with solving uniform motion applications. So that's pretty much our objective for today. We're going to use rate times time is equal to distance. So first of all, just a little refresh, okay, right? So if you have a car going 70 miles per hour and they go for 3 hours, what's the distance traveled? You know that that's going to be 210 miles, yeah? And then, so that's first rate times time is equal to distance. And then let's go ahead and practice solving for x here. We have x plus, and we distribute 1.2x minus 12 is equal to 98. And then this is going to be combine these like terms, 2.2x, right? Because this is an invisible one here. Minus 12 is equal to 98. 2.2x, we're going to add 12 to both sides, is equal to 110. So then divide both sides by 2.2. I don't know. Let's go ahead and figure out what that is. Here, 110 divided by 2.2 is 50. So x is equal to 50. Okay. And then here, convert 90 minutes to hours. How do we do that? Well, how many minutes are in an hour? There's 60 minutes in 1 hour, yeah? So if I do this, the denominator and here, these minute signs cancel out. And then this reduces to become what? This becomes 3/2 hours. And you're left with hours. So 3/2 or 1.5 hours, 1.5 hours basically. Okay. So let's talk about using problem solving to in distance, rate, and time applications. So first thing we need to do is we need to read the problem, and then we can create a table. And then we label those columns, we list the scenarios, and we write what we know. And then, of course, we're going to identify what we're looking for, name what we're looking for, and then fill in the chart, translate into an equation, and then solve, okay? So let's go ahead and do this problem. An express train and a local train leave Pittsburgh to travel to Washington, D.C. The express train, so we have two things. We have the express train, and we have the local train, okay? The express train can make the trip in 4 hours, and the local train takes 5 hours, okay? The speed of the express train is 12 miles faster than the speed of the local. So 12 miles faster than the speed of the local. We don't know what that speed is, so we'll let that be s plus 12. So then to fill out the chart, we just multiply across. We get 4 times the quantity s plus 12, and then 5 times s is going to be 5s, okay? And then it says here to find the speed of the both trains, okay? So in this case, we don't need this bottom one because they're going the same distance, right? They're going the same trip. So in this case, the distance is equal to each other. So we have 4 times s plus 12 is equal to 5s. And then we solve for s. So distributing the 4, we get 4s plus 48 is equal to 5s. And then minus 4s, both sides. And we get 48 is equal to s. So that means that the local train is 48 miles per hour. And that the express train is 12 more than that. So that's going to be 60 miles per hour, okay? All right. So let's try another one. We have Christopher and his parents live 115 miles apart. They met at a restaurant between their homes to celebrate his mother's birthday. Christopher drove 1.5 hours. So we have Christopher's here and his parents are here, and they met at a restaurant. So here's a restaurant, here's Christopher, here's the parents. And here's the restaurant. Oh man, that's terrible. Okay, so let's just say this is the restaurant here. Okay, so they drove here towards this, right? So, and the whole thing is 115 miles apart. Okay, so then let's see here. So we have Christopher, and we have parents. Okay, Christopher drove 1.5 hours while his parents drove 1 hour to go to the restaurant. Christopher's average speed was 10 miles an hour faster than his parents' speed, so let that be X. Okay. What's the average speeds of Christopher and his parents as they drove to the restaurant? Now, they both live 115 miles apart, and they met in one spot in the middle. So together, they traveled 115 miles total, okay? Now, 1.5 times the quantity x plus 10 represents the distance that Christopher covered. And then 1 times x would just be x, and that represents the distance that the parents went. Okay, so if we add this together, we have an equation here, 1.5 times the quantity x plus 10. So that's Christopher's distance plus the distance that his parents traveled, and together it's 115. Okay, so let's go ahead and simplify that. We have 1.5x plus 15 plus x is equal to 115. Combining like terms, 2.5x plus 15 is equal to 115. Let's subtract 15 from both sides. We get, moving over here, we get 2.5x is equal to 100. So then 100 divided by 2.5x, or 2.5 I mean, is equal to 40. 40 miles per hour. So that's going to be what? That's going to represent the parents, right? So that's the parents. But what about Christopher? It's 10 miles faster, right? He went 10 miles faster. So Christopher, or Chris, is going 50 miles per hour. And then the parents are driving incredibly slow. Who drives 40 miles per hour? I have no idea. Okay. All right. Let's do another one. Here we have 2 truck drivers leave a rest area on the interstate at the same time. One truck travels east and one travels west. So you have 2 trucks, one going this way and one going, one going west and one going east. The truck traveling west travels at, so we have one going west and one going east, yeah? The truck traveling west travels at 70 miles per hour. And the truck traveling east has an average speed of 60 miles per hour. How long will they travel? They both travel the same amount of time. They leave at the same time, yeah? How long will they travel before they are 325 miles apart? So you see how that works? Because, 70x represents the truck driver going west, and 60x represents the truck driver's distance going east, and then together, that's going to equal 325. So 70x plus 60x will equal 325. So let's go ahead and combine that. That's 130x is equal to 325. So let's go ahead and divide 325 by 130. Okay, so divide that by 130. 130, and you get x is 2.5 or 2.5 hours. Okay, not too terrible, right? You guys could do this. Okay, so let's do another one. This is the same kind of, we did that. This is the one we just did. This is the same thing, but that's okay. All right, so we have Pierre and we have Monique. This is more practice. All right, they leave at the same time, except that now Pierre drives north, right? He's going this way, and she drives south. So then we have 75 miles per hour. Pierre drives north at the turnpike at 70 miles per hour, 75, and Monique drives south at 68 miles per hour. So 68 here, and they both left at the same time. That's the hint right here, same time. So that means that they traveled the same amount of time. So that could be X right there. So then multiplying across, we get 75x, 68x. And then together, because they're going to be, they're traveling in opposite directions, that's going to be 429. So then let's go ahead and add. So 75x plus 68x is equal to 429. So let's go ahead and combine these two terms. We have here 75x plus 68x. That's going to be 143x is equal to 429. So 429 divided by 143 is going to be 3. So x is equal to 3. So it took them 3 hours to be 429 miles apart. Okay, so here we go. When Katie May walks to school, so we have to school, it takes her 30 minutes. If she rides her bike, it takes her 15 minutes. Okay, so now we're doing walking and then riding bike. Okay, so so it takes her 30 minutes, but see, look, the difference. So this one's interesting because first it gives us the time in minutes, but the speed is 3 miles per hour. So something is like not right, right? We have to convert minutes to hours. So 30 minutes to hours, right? Remember, we multiply by that ratio. That cancels out the minutes. Or we divide by 60, right? This is just 1/2 hour. We already knew that, but just to see it. So she walks, it takes her a half hour. If she rides her bike, it takes her 15 minutes, which is, you know, half of a half. So that's going to be 1/4. But just for fun, go ahead and look at how it's calculated. You know, 15 divided by 15 over 60. 60 divided by 15 is 4. So that's 1/4 hour. Okay, so that's 1/4 here, or 0.25 and 0.5. And then it says her speed is 3 miles per hour faster when she rides her bike. So miles per hour, so that's plus 3. Then when she walks, so that's our x, okay? So multiplying across, that's going to be 1/2 x here. And then this is going to be 1/4 times the quantity x plus 3. Okay, so now we don't need the sum because we're talking about how she goes to school. Just when she goes to school, the distance doesn't change. Yeah, it's still the same. Like it's still however many miles away, that's how far it is away. So these two expressions for distance actually equal each other, okay? So it's really important that you read the problem carefully because sometimes it's like an add up and equals to kind of a problem, and other times it's an equal to each other kind of a problem. So in this case, it was an equal to each other kind of a problem, okay? So let's go ahead and multiply across. Well, one trick you could do here, by the way, just, you know, I know it doesn't talk about it very much in the book, but this is has an LCD of 4. So let's see what happens if I multiply both sides by 4. It's still okay, right? So this actually will cancel out on the right-hand side, and then 4 times 1/2 will be 2x. So now you just have 2x is equal to x plus 3, which is a lot nicer than dealing with those super fun fractions, you know. So now we're solving for x, and we get x is equal to 3, okay? All right. And that gives us what? That gives us the speed of walking. So walking speed is 3 mph. And then bike speed is 3 miles per hour faster than that. So that's going to be 6 miles per hour. Okay.